Hello, everyone. This is the very beginning of Unit 5 for my environmental science class. I'm Mr. Baker. This unit, we're going to talk about the hydrosphere and cryosphere, so talking about all the water on the planet of the Earth, and the atmosphere is going to kind of flow out of that as we move from water to air, and then we're going to talk about climate and climate change. So we are going to talk a little bit about weather here as well as we move through the atmospheres section. This is going to be a little bit longer unit. At least that's the way I'm planning it right now. So be on the lookout for some quizzes and a test along the way. So the first thing to discuss is how Earth's water sources are distributed, and we're going to answer the question of why fresh water is a limited resource, and it may even be a non-renewable resource at times. So on the planet Earth, about 96.5% of all water is in the ocean or is considered salt water. It is salinated, sal meaning salt here. The rest of that, the 3.5%, is freshwater and can be used by humans, but about 31% of the freshwater on the planet is viable for use by humans for drinking and considered safe drinking water. May even be a little bit lower than that due to some contamination and some pollution. So this is a map of the US with rivers and watersheds added to it. So those different colors all represent different paths that water can take once it's hit the ground and moves towards an ocean. So you can see the real big one is towards the Mississippi River. Here in Ohio, all our rivers eventually flow towards the Ohio River and then towards the Mississippi River and the Gulf of Mexico as we travel effectively down this line here and out into the Gulf. So watershed is the area of land that the water falls on, where it eventually will lead to the same destination. Now, yes, all oceans are connected and whatnot, but we're talking about the same point where the water will cross from being a river into an ocean. All right, so this includes streams, it includes creeks, it can include lakes, though generally lakes are left out of watersheds. All right, these are all fresh water. They are all sources of drinking water as well. As that water sits and passes through the watershed, it may also end up infiltrating the soil and being trapped in an aquifer. An aquifer is where there is a layer of permeable soil above a layer that is non-permeable. So the water seeps into the soil and then is trapped above a layer of rock or a layer of soil that the water can't travel through anymore. And we can actually pump this water back up out of the ground and use it. Here in central Ohio, most of our water comes from this aquifer here that's dark brown, and is, if you're living in Columbus, is usually pumped from one of three sources. Now, you might be on well water depending on where you live, but those wells are also pulling from the same aquifers. Now, aquifers can become polluted and they can dry up. Generally, what happens, though, is the aquifer sinks below the water level in the aquifer, that is, sinks below where the wells are placed. So the well will have to be driven deeper under the ground to be able to pull that water up again. And this is a natural thing that occurs as water is used up, but humans are tapping into this much more frequently than, say, like plants are, or crops would if they weren't being watered. As water gets trapped in an aquifer, it is kind of sequestered. Usually it's no longer polluted. It isn't at risk of evaporation because it's underground. Plants can use it, but most plants do not have roots that will tap into an aquifer. That's way deeper than what they would use. Right? The other places that water could be on the Earth is frozen solid, right? It could be ice. So it could be in a glacier or an ice cap. It could be as snow. Sometimes snow will sublimate directly into water vapor or it will deposit back into it. All right. If the ice floats on a river or a lake, it could also be over a sea where we have sea ice, which isn't connected to an ice sheet. Icebergs break off of sea ice or from ice shelves. Ice shelves are connected to an ice sheet that sits above ground. All right, so we're thinking Antarctica is an ice sheet, but in the Arctic, there is only sea ice. All right, glaciers and permafrost are above the air, usually above the area in the altitude. That means higher up on the mountains like this, where it's going to continue to stay below the freezing point of water, 0 degrees Celsius, all year round. Glaciers aren't always, though. As the atmosphere has increased in temperature over the past hundreds of years at least, we have seen glaciers melt because they are below that permafrost zone. Right? So we all know and love the water cycle, right? You saw this way back in like 5th grade. This one's a little bit more complicated than that and has a little bit more information to it. So we're not going to walk through every single little bit of this, but as the sun heats the earth, it's going to introduce thermal energy. And this thermal energy is going to allow for evaporation and evapotranspiration. Evapotranspiration, I added an extra O in that word, to bring water off of the ground, off of the ocean, off of any standing water, as well as bring it away from plants. That's transpiration or evapotranspiration. Ice can sublimate, snow can sublimate as well, and it's going to raise because it is warmer. It is less dense, so it's going to rise in the atmosphere. Once it gets to a certain point in the atmosphere where it's cold enough, it's going to condense back into a water vapor that's a little bit more solid. It's still not solid, right? Clouds aren't solid, but it's more solid than being a gas, right? So once condensation has occurred, it will continue occurring in the same place until it reaches a point where those water droplets are heavy enough to fall back down to the earth as some kind of precipitation, right? Snow, rain, hail, freezing rain, it doesn't matter. That's all precipitation, right? And it's going to come back down to earth. It could also be through fog, where the fog is going to be a very low cirrus cloud, and it's going to be actually touching the ground at times. That could have something called fog drip. Right? But once the water hits the ground, it's going to go through surface runoff. It's going to get absorbed by plants. It's going to flow into rivers and streams and discharge into wetlands or rivers or freshwater lakes or seas or oceans. It may also infiltrate and soak into the groundwater or into an aquifer, right? This is called recharge, and it builds that aquifer back up. Like we talked about, the aquifer goes down and it can go back up, especially in the spring when we have snow melt occurring and all the snow that was up on the mountain melts and flows down the mountainside, right? Once it gets back into standing water or back into a plant, evaporation and evapotranspiration can occur again, and the cycle will continue. All right. So if it's in the ocean, it is salt water, right? It is, or if it's in a saline lake like the Dead Sea or the Aegean Sea, we aren't able to use it, right? It's not fresh water. Now, a water source like a lake or a pond can also become polluted, and we're going to talk about more about that next section. But if it's polluted, we as humans can't use it, and that's why we consider fresh water a limited resource, and it's non-renewable, right? we can't just make more water. We can desalinate water so that it's not salt water anymore and is fresh water. It's what they do a lot in the western U.S. near California, Washington, and Oregon. But once it's polluted, it's polluted. We have to either clean and treat that polluted water, or we're just unable to use it anymore. All right, so we've talked about how the Earth's water sources are distributed. We've talked a little bit about why fresh water is a limited resource. This week in my class, we're going to continue working on this and continue going over it. If you have any questions, send me an email, reach out to me. If you're not a part of my class, you can leave a comment below, and I may or may not get back to those. We'll see how it goes as time progresses. Have a good afternoon and keep on learning.